Good evening, everyone. So, welcome to this extra class session. The meeting will begin in about 5 minutes because we understand that since it's on the weekday, some of our colleagues are yet to join. However, the number here is 15, and then we just give it 5 minutes. It's now 7:02, so let me just say at 7:05 we are going to start. So not 5 minutes or 3 minutes. We are going to start the meeting immediately. Do your best to follow through to the end, pay close attention and listen attentively. Everything that was covered in the previous lesson will open up and explain further. Thank you for joining the meeting. We ask for patience, just 3, 4 minutes, and then we'll begin. All right, everyone. So, good evening once again. We are beginning the meeting right now. In the name of God, the Father, the Son, and the Holy Spirit. All right. So, in our last session, or in our first, which was the most recent session that we had in class, your lecturer discussed or mentioned a few things concerning the intricacies of this course. It says the He mentioned that the whole point of the course is to help you understand better how the computer functions. Seeing as we are going to be IT students, then you need to know the ins and outs of a computer, how it thinks and how it works. So I'll put this question to you. If you have an answer to it, you may raise your hand and share. If you have no idea, don't worry, keep your hands down and we just proceed. Time is of the essence. All right. So, think of it. If information is given to a computer, how do you think when you hit something like a single key on the computer's keyboard, how exactly do you think this key, the key that you hit, was somehow able to be displayed on the screen of a computer as the exact letter that you dialed? Has it ever crossed your mind that this particular thing is a fascinating concept? I just hit that. Yes, Mr. Joshua, you may unmute your mic and speak.
Okay, thank you, sir. It processes it and brings out a result.
Exactly, exactly. So it says it processes it and then it brings out a result. Now, this idea of processing and then results, bringing out results is exactly what this course seeks to study. So this course seeks to study and understand how this processing and then results presentation is done. Then comes in the little man computer. Now, what is the little man computer and why did the professor introduce it to you in your first lesson? Little man computer is basically a model that is used to help beginners understand exactly how um, that's it's used to help beginners understand exactly how the inner workings of the computer are. So it features different parts that come together to work, just like the central processing unit of a standard computer does. So then it is not a real software, not scratch that. It is not an actual computer. Let me put it that way. Good. So the little computer is not an actual computer that has physical hardware, no, but rather it is a simulator that shows how the inner workings of the central processing unit of a standard computer is. Yes, Frank Ajikun, you may unmute your mic and speak.
Yeah, friends, please, good evening.
Good evening.
Please, some of us, we are working, so can you please go slow for us, okay?
I should go slow.
Because you are going fast, like it seems that you are going fast. And then last weekend too, we couldn't join because of the network issue, so can you please go slow for us?
No problem. I got you, Sarah. I got you.
Okay.
All right. Okay, so I'll start over. As I was saying, this course here seeks to teach IT students just how a computer works on the inside. We have learned a lot concerning computers. We've learned about the history and the build-up of what led to the computers we have today. However, we shouldn't lose sight of what happens inside the computer since we are going to be IT students and then the IT front line of the future to come. Then we should have the mastery over the inner workings of a computer. This course seeks to teach you exactly computers organization and how it is built, how a computer works, how it thinks, how it processes data. I started by asking a question that what do you think happens when you hit kill and then it suddenly displays on the screen? So you hit kill on your keyboard, but somehow it is shown on your screen. How does a computer run these things? Then one of our colleagues responded saying that the computer takes that information, processes it, and then it gives it back to us. The aim of this particular course is to study that small frame where the computer took the data that you gave, processed it, and brought it out. And one of the ways that we are going to do that is by using this little man computer. The little man computer is not a true hardware device. It is not a computer. What it actually is a software that helps beginners understand how a computer thinks, processes information, and gives out outputs. So it is basically a deep look into the computer's brain. So this little man computer simulates, it's a simulator that shows how instructions are taken and run on the inside of the computer's brain. That's the central processing unit. So I am Prince Wilson, as you can tell from my page. We are moving on to the lesson. So please follow closely. And then if you have any problems whatsoever, do not hesitate to raise your hand and you will be addressed. All right. So by the end of the lesson, we should be able to, every learner should be able to explain what the little man computer is. You should also be able to identify and describe the key components of the little man computer, understand how the little man computer executes instructions using the fetch, decode, and execute cycles. You should also be able to write and then trace simple little man computer programs. We will come to that too. And then we should be able to relate the concept inside the little man computer to an actual computer system. So remember what I said. A little man computer is not a true physical device. It is merely a simulator that shows how the inner workings of the central processing unit happens. So it is not a physical device, it's a simulator. All right. So now, why what is the little man computer about and why is it important that we study it? So let's look at that. So now it says inside the black box, you understand what happens when a program runs. A lot of people can see programs running, but we cannot really tell what is happening on the inside. Yes, Louis Kofiman say, let me hear you speak.
Good evening, sir.
Yes, please.
Please, some of us, due to the nature of our work and where we are, I'll just briefly want to know, would the lecture be recorded so that on a good time we can also play it and review everything?
All right.
Thank
So,
you.
Mr. Kofi Mante, yes, the lecture is being recorded, and yes, it will be uploaded on a YouTube page where you can easily access it in due time. So,
Oh,
yes,
okay.
please.
Thank you very much. Please, sorry
Yes.
for the interruption. Please continue.
There's no problem. Abuaje Prince, please unmute and speak.
All right. Thank you. Good evening.
Good evening.
Please, I'm kind of new with this. How do you call it? Meet thing. Somebody is. They say a participant has started an annotation or something like that, and is blocking my view. Please, how do I go about that?
Okay, so the annotations, you see it as a big notification and it's blocking your view entirely. The thing is, I am the one who is doing those annotations because I'll be writing and doing some illustrations on the screen. So then, seeing as it's blocking your view, it's a little bit uncomfortable. Is everyone facing the same challenge?
Yes, sir.
Every single one of you.
No, I'm having.
Yeah.
I'm
Think
not.
No,
it's
not
mine.
all
It's
of us.
mine.
Not all of us.
Not all of us.
Oh,
So it's okay.
okay, so I hear you. So I'm going to stop the annotations, but if I am to write on the screen, I will have to bring it back up. Else, I'll just have to change my file into a PDF file, and then I'll use Google's annotation. I think that one will not interfere. All right. So
Thank you. Thank you.
for now, I'll just take it away. Okay. I'll just. How about now? Does it still display?
It's perfect now.
No,
It's
that's
all
it.
right. All right. That's cool. All right. Let's proceed. So now, as I was saying, this one here, the black box, we are trying to understand what exactly happens inside the computer. So it says very few people, even in the IT world, those who are into IT these days only focus on the externalities, programming, and etc. etc. But very few understand what happens on the inside of the computer. From software to hardware, apps rely on the hardware to execute instructions step by step. Connecting the two worlds, knowing the software and the hardware interaction improves coding and debugging. I believe there is a hand up. Oh, okay. No hands. Please, the other organizers, let's be mindful of those in the lobby so that we can admit them. All right. As I was saying. All right. So the foundation for advanced topic. This knowledge enables learning assembly, language, operating system, and then processor design. So then this is the reason why it's important to study computer organization. We understand what happens inside the machine. We understand that software relies on hardware and hardware relies on software in order to execute instructions. And we are able to connect the two worlds of software and hardware. And finally, and this builds an advanced foundation for studying and then mastering advanced concepts inside the IT field. All right. Now, what is the Little Man computer? So the Little Man computer, LMC, is a model. It's not a physical computer. So it is merely a teaching tool that simplifies the real-life operations that computers undertake. But it does it in a way that is easy to understand for beginners like ourselves. So then it mimics the real architecture of the central processing units. Even though it's imaginary, it reflects the actual way that the central processing units really works. So despite the fact that it is going to act as an imaginary computer, it is simulating exactly what the central processing unit does. Just that this one only uses few instructions and then processes few data and brings out few inputs. But a central processing unit will do what we are going to do with a little computer several times in a split second. That's the only difference. So we are going to tone down what a CPU can do and bring it to a humanly understandable level. The purpose of this little man computer is to teach beginners how instructions are stored, fetched, and executed sequentially. So now it says the little man computer has a structure like what you can see over here. It has mailboxes. We'll look at them later. But think of the mailboxes as storage areas where we are keeping information. So when you put something to the computer, it stores them inside these mailboxes, We'll see what the mailboxes are later in the lesson. So we will relate them to their real life components. The user gives an input, the computer reads it. The computer may store some inside there. The computer may retrieve some from the mailboxes. After it gets that, it puts them into the accumulator. The accumulator is basically the computer's calculator. And its job is to perform operations on the inputs that the user has given. So when the calculator performs these operations, it finally brings out a result, and that is writing. And that will be displayed to the user, the output. And this is what we are going to be doing using the little man computer. All right. The little man computer analogy. So the little man follows instructions. The little man follows instructions. It has 100 mailboxes from 0 all the way to 99 for data and instructions. So to hold this data and instructions, the mailbox is coming. It has an in tray where the user gives an input. So you're going to see that later. I'll show you a little man computer right now and you'll see how it works. And then it has an out tray for bringing out user inputs. And it also has a calculator that will do operations on the inputs that you'll be giving. And then it also has a program counter. The essence of the program counter is to ensure that program is flowing in a particular order. So it's always storing an address, and then tells the computer that after you are done, it tells the processor that after you are done with this, continue to this side. Okay. And then it says the little man is like the CPU. So the little man computer, the analogy is based on an actual little man. So then look at this image you are seeing here. This little man you see standing here is the central processing unit. Okay. Now he fetches instructions from the mailboxes, that's memory. So let's say a user gives an input and stores it inside this box here, 01. A little man is going to go to that box and take that information. Taking that information from the box is called fetching. I think it's easy to attribute the word fetch to taking information from a storage area, right? So then the little man goes to these boxes and fetches the information. He retrieves information that the user puts inside as inputs. Now, he takes them from the memory, which are the mailboxes. Then he processes them with the calculator. Now, the real life calculator is the arithmetic logic unit. That's the ALU. We know that its job is to do computations, mathematical operations is the job of the ALU. So then after he takes the information that's fetching, he brings it to the arithmetic logic unit. And what does it do? It processes it. See that? It processes it. So it runs programs on it. It does additions, it does subtractions, etc., etc. And after doing this, it uses a tray for the inputs or the outputs. So then the input is where the user gives the information, and then finally it will come out with the outputs. He follows one instruction at a time, just like a real processor. So even though he works slower, he also follows one instruction at a time. So remember, according to this analogy, the central processing unit is the little man, the arithmetic logic unit is the calculator, and then the program counter is a notepad where we keep writing exactly how we want to flow with our program. So after I do this, I am going to go here. I write it down in my notepad. That notepad becomes the program counter, PC. So the little man is the central processing unit. The calculator is the arithmetic logic unit, and the notepad is the program counter. Right. Are there any questions so far before we proceed? All right. Let's continue. So now, components of the little man computer. So now let's see what these components do. We start with the little man himself. The little man, which is the central processing unit, fetches data, decodes the data, and executes instructions. So fetching data means the data that the user has given to the machine, the central processing unit retrieves it from storage. After retrieving this information from storage, it decodes it. It decodes it means it's going to run it and then change it into a way that it will understand. After understanding it, it executes the instruction. This means it's going to follow step-by-step codes, and in the end, it will do exactly what the user wanted that input to become. Organizers, please be used to this person.
Mr. Joshua Tampon, please mute.
All right. Thank you very much. We proceed. So let's keep that in mind. The little man, which is the central processing unit, fetches the data. So goes to take the data from storage. It decodes the data and it executes it. And remember, these are the three main functions of the central processing unit. Always, if you are asked, fetching, decoding, execution. Fetching is retrieving data from storage. Decoding is making data into understandable forms for the computer. Execution is giving the user a desired output. Now, we come to the second aspect of the little man computer. That's the mailboxes. The mailboxes are this analogy's equivalents of the RAM. So we know that the job of the RAM is to store information temporarily. So now this RAM here inside the little man computer, we say it is the mailbox. Now it says each one can hold a 3-digit instruction or data. This means starting from 0 all the way to 999, it can hold data values in this range. So 0 to 999, it can hold all this data. So we started by saying it has exactly 99 mailboxes. And then each mailbox can hold exactly 0 to 999. So each mailbox can hold up to 999 data. In other words, 1,000. 0 will be the first, 999 will be the last, making it exactly 1,000. Now, the third structure you should look at, so remember the mailboxes are the RAM, they store. The third structure you should look at is the accumulator. The accumulator is a temporary storage register where arithmetic is done. So now it also holds information, but this one holds specific information. It holds information that is being processed. And then as the processing is being done, the information will still be held in the accumulator. So what this means is that let's say I have data stored in this box here, 500. So that's my mailbox, the one labeled 500, the RAM. And I want to add it to another data that has been stored in this box here, 101. I am going to take the data from 500, feed it to the mailbox, feed it to the accumulator over here. Then I'll take the data 101 and also feed it to the accumulator. And inside the accumulator, if I want to do an addition, it is going to combine 500 to 101. In the process, it will be storing the data as well as processing them. And after it does this, once one of the lines of code I write is passed, the program counter will update. So for every single instruction that is executed, the program counter updates. So currently, if we are here to start the program, the counter is at 0. After one line of code executes, the program counter will go to 1. After another instruction is executed, the program counter will go to 2. So then it keeps bringing up the new one. So we started from 0. After 0 is executed, program counter goes to 1. After we do the program at 1, it updates to 2. After it does at 2, it updates to 3, and it keeps going all the way to the end. So it always holds the address of the next instruction to execute so that it maintains order. So that way, if we have done 0, instruction number 1 is given as 0. And then the program counter sees that we have finished 0, it is immediately going to update to 1, prompting the computer that the sequence you should follow is from 0, follow up to 1. After 1 is done, the program counter goes to 2, and it keeps going on all the way to the end. So it says it holds the address for the next instruction to be executed. So let's go over that. Little man is a central processing unit. It fetches, decodes, and executes the data. Instruction, sorry. The mailboxes hold the data. There are 99 mailboxes, and each one can hold up to 1,000 data, starting from 0 to 999. And then 3-digit instruction data is actually 3 digits. Then we have the accumulator, which is basically the arithmetic logic unit equivalent inside this program. What it does is it holds data whilst arithmetic is being conducted on the data. So whilst your addition and subtractions are being done on your inputs, the accumulator stores them temporarily and does those things for them. Then the program counter tells the computer where to go next. So it holds the address of the next instruction to be executed. Am I making myself clear?
Yes.
Yes, sir.
All right. So far, so good. If it's been good so far, let me know. If you have a question, feel free to ask. Because as we proceed further and progress further, we'll start running into the little man itself and we'll be running a few instructions there. So ask your questions now so that they do not interfere with the lessons later. So I assume there are none. Let's proceed. So now, It says the little man computer versus its real life. Okay, Ebenezer Nyako, please let me hear you speak.
Please, I would like to know, should in case someone is working on a program, like if somebody is programming and let's say the memory is faulty, would the outcome be effective?
If someone is working on a program and the memory
Yes,
is
please.
faulty, you mean to say, like, for
Yes, please.
example, the RAM that stores the instruction, sorry, the inputs that the user gives is faulty, or
It's
the
faulty.
program, yes, so you're asking if the program will be effective.
Yes, sir.
All right, so then let's think about it this way. It's a good question. If you have two boxes and then you are putting two different informations in them, one is a broken box. Maybe you are putting into it the number 5 and you're putting another number 2 inside a different RAM storage. So a different RAM box. And in the end, you tell the computer to combine the one in the first memory. That's the first one where you put 5 with the second memory where you put 2. Even though it might successfully retrieve information from the box with 2, due to the error it will encounter when it is trying to retrieve from the damaged RAM storage, it is not going to be able to run the program successfully. So now, if you can somehow bypass that very faulty memory storage area, then your program might run, but it will not be able to display exactly what you wanted, because this will mean that one of your inputs has been overlooked. You understand what I'm saying?
Yes,
Mr.
please.
Ebenezer. Yes. So if the storage is faulty, this will mean that it will affect your execution because it has to retrieve data from the RAM on any whatever input you give it will be immediately stored somewhere. And you can direct it as to where to store it. Now, if you store it in a storage area that is damaged, retrieving that information becomes possible. So impossible, sorry. So for that reason, your program will not be effective. Okay, so I hope that answers your question.
Yes, I clearly get it. Thank you.
All right. Yeah, thank you. Thank you too. All right, so the little man computer components, we start with the little man himself. The little man is the real life equivalent of the central processing units. Then we have the mailboxes. There are 99, 100 of them starting from 0 to 99. And then that is the random access memory. That's your RAM. And there is the calculator, and it is the arithmetic logic units, ALU. And there is the in tray and out tray, which are your keyboard and mouse for input devices, and then the monitor, which is an output device. Then there is the program counter, which is the program counter register. So it represents exactly what it's supposed to be. And then there is the accumulator register, the accumulator, which is the accumulator register. Okay, so then this program counter, accumulator, they represent exactly what their real life counterparts are. So they are registers. Let's keep that in mind. All right. Now, the instruction cycle of a computer. The instruction cycle of a computer starts with fetching, decoding, execution. Then we move on to the next program. So the three major parts are the fetch, decode, and execute. Fetching is what happens when the little man reads the mailbox. So he goes to the RAM storage area and then he gets information out of it. So he goes to the mailbox instruction pointed by the program counter. So the program counter is on 00. It says fetch instruction from 901. So if 00, if there is a code written, the codes that will be written, each one is numbered by the computer. And then the program counter targets the codes one by one. If a line of code says that fetch data from box 206, the program counter will read that line. So if that line is 00, program counter says 00 means fetch data from box 206. Little man will go to 206, view what is over there, and then he takes it. And when he takes that, he comes to the decoding. So someone else. Right. So then there is decoding. The program counter will take the little man takes the information and then now he decodes it. Now it says he interprets the instruction. Example, if 901 means input INP, then he's going to take an input from the user. After doing that, so that is the decoding. He takes the number and then he gets an input from the user. So then the user does not speak in numbers, the user speaks in natural words. Then the machine will decode what the user has said. Then The next in line will be the execution. The execution is performing of the action based on what the user has given to it. Okay, so then the input is taken, it is given to the accumulator. The accumulator will do the work of the arithmetic logic unit, it performs operations on that. And after it does all these things, the program counter moves from one state to another. So it always updates in steps of ones. Every line is counted as a single one. There are times when the program counter is allowed to jump, and then we'll come to that later in the lesson. But for now, we are still on the basics. Now, it says the program counter increases by 1, and the cycle repeats until HLT. HLT is an instruction in assembly language that is used to say halt. In other words, it is used to tell a computer to stop running a particular program. So the program is going to keep cycling and cycling until it comes by a line of code that tells it to stop. So without giving it a stop or a halt command, the computer is going to run endlessly without ever coming to a stop. Keep that in mind. Now, common instructions in a little man computer. We are going to pick a few major ones, and I want you to look at them closely because after the next 2 slides, we are going to jump right into little man, and then we are going to use it to write a few programs. So it says here are the common instructions in a little man computer. Inputs. INP is for inputs. If you will recall our lessons in previous times, we mentioned assembly language. An assembly language is a language that is one of the lower level languages that humans can somewhat understand, and then it uses mnemonics. So it uses mnemonics like this INP, OUT, LDA to give the computer instructions. So then it says, if you want to tell the computer that I'll give you an input, to use INP. Quite simple to keep in mind, INP. So it says, get input and store it in the accumulator. Then it has out. Mr. Joshua, please mute all participants, okay? All right, sorry for whoever that was. I said Obi was spirit team right now, doing some serious worship at church. Then why join the class? All right. As I was saying, so the outputs is what the OUT that's out is what you use to tell that the value to give, bring out or display something. So input is to take data, output is to bring out data. Then we have LDA. For now, what I want us to focus on right now is this one, SCA, which is for storing data. So we are going to look at inputs, outputs, storage, addition, subtraction. These branch codes, we'll look at them later. But for now, we are going to look at input, output, storage, addition, subtraction, and then also the halt program. So please keep them in mind. There is INP for inputs, there is outputs, there is storage, there is addition, there is subtraction, there is halt. And we are going to be using this to write simple programs. INP to take input, OUT to bring output, SCA to store data, to HLT to halt, SUB to subtract, ADD to add. Is that clear? Now you see the codes that you're seeing inside the boxes over here, inside the brackets here. They tell the computer which register it should visit. They tell the computer which exact Felix Freeman Asante. Yes, please speak.
Can I be heard, please?
Yes, you can be heard.
Yes, please. I've looked at the common instructions, and there is one that I think I don't see.
Yes.
D8 that.
Come again.
D8 that.
All right. Okay. All right. Okay. So thank you, Mr. Freeman. So currently, right, there are so many common instructions to use. However, as I said, we are only going to visit input, outputs, storage, addition, subtraction, halt. And then later in our lessons in the future, we are going to come to other forms of data, instructions to give. If I overload you with all the instructions, it's going to be hard for we to interpret. So please bear with me. For now, we are just starting. So overloading you with information will do you more harm than good. However, if you wish, after the lesson, we can share a list of instructions for you, and then you can go and use that. But for now, we are starting with this. Okay. So don't worry, later in the lessons, every other one, if time permits, will be visited. We just want to see how far the professor is willing to take us through with this little man computer setup. If it needs to go very far, then we'll also go deeper into it. However, if it's just a small stone, a small stepping stone to other greater concepts in the course, then it means we will study just the surface, and then as time moves on, we move on to more pressing issues. So thank you for the heads up, Boss Freeman. So it's as he has said, there are several other instructions. These are not the only ones. Even if you look on the image right here, look here, it shows different. It shows INP, it shows ADD, it shows out, and it also shows BUT. It shows HLT, it shows ALL. So there are different ones. They are just looking at simple ones that we can actually use in the beginner setup. That's INP. And there is OUT for outputs. There is STA for storage. There is ADD for addition, SUB for subtraction. There is HLT. The BRA, BRZ you are seeing are branch codes. We'll see that later. All right. So now it says, here's an example. Adding two numbers. You give the computer an input. The accumulator will take that input, and then it processes it by taking data from storage, combining it with another data from storage, and bringing an output. So now it says IMP here into the accumulator. Storage will save into the mailbox. We are going to use this right now to write a code, so don't worry, understanding will be met, everybody. The inputs feeds to the accumulator as well, and then there is an addition done. We're going to look at that very soon. And then the output results, the results are outputted, and then HLT stops the program. So it takes the data, it takes data from the storage, it combines it, it says add to data, the data stored in 10, and it gives an output, and then the program halts. All right. So now let's answer these questions quickly, and then once we are done answering them, I show you what how a little man setup looks. Okay. It says arrange the steps of the fetch, decode, execute cycle in correct sequence from the first to the last. So please, you may raise your hand, and then you can help us arrange this. So we are trying to trace the path that the little man takes to solve simple issues or to run user instructions. Yes, Abuaji.
Yes. So if I understand the question, we have to arrange it in the order where the little man computer works. So we will go first with the fetch instruction. Then we go with the code instruction.
Okay.
Then execute to increase program counter.
All right, excellent, excellent. So it says we fetch, we decode, we execute, and then increase the program counter. Okay, that is what Abuaje Prince says. There's another hand up. You may unmute and speak. Number 2.
That was the same thing I was going to say. That was the same.
Oh, okay. All right, all right. So then let's look at the next slide. The answers are right there. So as he said, number 1 is to fetch instruction from memory. Decoding comes next, execution, and then program counter is updated to tell us where to go next in the program. All right. So now, common mistakes to avoid as we are about to start our little man computer coding journey. It says forgetting to store data before using it again. So if you do not store data, it is not even hard for, it is impossible for the little man to retrieve data that is not stored. So whenever you do an input, give it a place to be stored so that the computer can retrieve that. Second one says using the wrong mailbox addresses. If you store a data in 10 and then you want to retrieve it and you mistakenly say retrieve data from 9, the computer is going to keep giving you empty retrievals because you are giving it an empty address. You have stored in one box and you're asking it to retrieve from another. So always take note of what you have stored. Second one says not clearing the accumulator between operations. So when we are doing different operations, you have to make sure that the accumulator is updated with every single one you do. Omitting halts, the program will run forever. So when you omit halts, the program is going to keep running endlessly. Confusing load with storage. Remember, you shouldn't confuse loading with storage. The accumulator is the only place where mass happens. Let's keep that in mind. All right. We are going to course here now. We are going to look at the little man computer setup and we are going to write a few programs. If you have any question concerning this, ask now before we start the main day. Okay. So now here is a little man computer, a central processing unit simulator. So I just introduced you to exactly what it does, and then it simulates just how the central processing unit runs inside a standard computer. Over here on this side, so everybody follow me with your eyes to this very side. What you see over here are going to be the programs that we are going to give to the little man computer. The programs written here will decide exactly how the computer should deal with the input that you'll be giving it, as well as the output. So this particular one I'm using here is known as little 101 computing.net. So you can search this right now, and then if you have your machine with you, you follow along as we do our things. So then www.101computing.net, it should bring you to this very place. So let me copy this link and drop it inside one of the platforms. I'm putting this on the official platform so you can access it and then use it. Okay, so I have dropped the link on the platform. So you may use the link to access this little man computer simulator, and then you follow along as we go. So now let's first look at the things that we were talking about inside the lesson, and then let's follow with our eyes. As I said, this region here is where we are going to put our programs, the programs that will be executed by the little man computer. Now look at the program counter. The program counter is, if a code should run on this level, the program counter is going to count it as number 1. So for every single code that you run, every line of program that you run, the program counter updates. After input 1 is run, program counter will update to 2 to tell the program that jump from that one to the next one. So this is input 0. Program counter will record it as 0, as 1, sorry. And after that is run, it goes to this side. After that is run, it goes to this side. After that is run, it goes to this side. The program counter will keep updating all the way to the last inputs. So you will realize that at the end of all the running, we would have run 1, 2, 3, 4, 5, 6, 7, 8, 9. The program counter will be standing on the number 10. 10 because it is telling the program that we have halted on the last line. So then we have stopped. Okay, so whenever you run a program, realize that the program counter is 1 more than the number of lines that you wrote. All right. And then we have MAR, that's the memory address register. That stores the address of the current memory that you want the little man to visit. And then we have the yes, hello. Okay. Okay, so we have the memory data register. Memory data register will be storing the exact data. So memory address register tells the computer that the memory the user brought is stored in address 10. Memory data register goes to that address and retrieves the data, and then the data is stored over here. Then we have the central instruction register, that's the CIR. The function of the CIR is to keep the exact instruction that the user wants to be executed. So maybe the user says that take the data that was stored and then subtract 5 from it. So the central instruction register stores that exact instruction. And what the accumulator does is it now takes the data that's in the memory address register and executes it based on the central instructions register's instruction. And after it does that, it is going to deliver an output here. So the user input goes here. The computer is going to prompt you. It's going to give you a prompt somewhere up here to enter an input. And once you enter the input goes here. Then the program counter follows through and forward tells the computer how to run the instructions for that input. Then the memory address register goes to retrieve and stores the address of where the data or your input has been given. Then the memory data register goes into that address and then retrieves the information and stores it in itself. After doing that, the central instruction register stores the exact instruction to be executed. And then the accumulator takes that instruction and works on the address on the data using that very instruction, and then finally it displays an output. Okay, so this is a breakdown of how the central processing unit works. It flows from the program counter to the memory address register with the address, to the memory data register with the data, central instruction register with the instruction, then accumulator running the instructions on the data, and then finally outputs to display. Remember that the user feeds his input to the computer. All right, so now I want us to write a short program using what we just learned concerning the codes inside the little man computer. So let's write a short program that does simple things. First, the program should be able to take input from the user. It should be able to store the input at a particular memory registry. It should be able to add that input to another input. And then finally, it should be able to display the output, and then the program should stop running. Okay, so remember what we are doing. We are taking an input from the user. We are storing the inputs. We are adding the input to something else, another input. And after doing the addition of that input, we display the output, and then we stop the program. So now we are going to make use of all the instructions that we learned. Okay, so I'm going to clear this space so that we can put in our own instructions. So now follow me with this one. So we are going to take an input from the user. Remember, how do we take an input? Who remembers the code, the instruction that is used to take input from the user? If you do, tell me now, and then we proceed. Yes, the requiring. Let me hear. INP, exactly. Thank you. So then INP, as he said, to take input from the user. So then what this means is that when the program counter is running, it is first going to run INP, meaning it is going to allow the user to enter an input. So what we are doing here is we are giving them programs by which they are going to process the data that we'll give them later. Okay, so we are programming, but on a very basic level. What we are doing right now, we are using mnemonics, and then this is very close to assembly language. Pay close attention. Then we take the input from the user. After taking the input, what comes next? Remember, after taking the input, what comes next? We said there is no way you can get inputs if you do not store it. So then there is storage. So the requiring, you went already, your hand is already here, but the person after the requiring come next. Okay, Vida, let me hear you speak.
This LDA.
LDA. Okay. Vida says, so please mute your mic, sir. Vida says LDA, that's load, right? We are loading an address. Yes, what about the requiring? What do you have to say? Yes, Mr. Derek. Okay, the person after Derek, please, you may speak. All right, okay. Mute your mics then, mute your mics. Thank you for your contributions. So, please, Nipana OTA Politics FM, please mute your mic, okay? Okay, right. So I was saying that after the user gives an input, yes, Mr. Joshua Hanan, okay.
Yeah, hello, Wilson.
Yeah.
Please, can you decide to write the input in full?
No, you can't write the input in full. So thank you for asking that question, and let's see why you can't write the input in full. These instructions are like, you see, when you were coding in C++ or when you are coding in Python, there are particular words that whenever they are given, like cout to display outputs, cout exactly tells the computer that this thing needs to be displayed. You cannot write cout in any other form because it is a particular instruction that has been coded into the computer, and then it is the only thing that the computer understands. So this INP you are seeing here, even if you write it in small letters, it will still be a problem. It must strictly be in capital letters because this program here, the little man computer here, has been made to recognize INP as a particular line of code. This means changing INP will give it something that it is not familiar with. Therefore, it will not recognize this as an input receiver. So, Mr. Joshua, no, you cannot write it in full, okay? it should be in capital letters and it has to be INP, just like this. Is that clear? All right. Now, to Vida. Vida said we load address, but then that is a wrong step to make. The reason being that when you are loading, it means you have data stored somewhere and you are trying to retrieve it and use it, right? How exactly do you retrieve data that you have not yet stored? So then whenever you give the computer an input, storage is important. You have to store this data so that if you will perform operations on it in the future, the computer will be able to reference the storage, extract the information, and use that for the operation. So the next thing to do is storage. Who remembers the instruction for storage?
STA.
STA, excellent. So STA is the instruction for storage. All right, so you may put your hands down. So SCA for storage. Now, whenever you write SCA, we have to give the computer somewhere to store the information. So now you notice all these yellow numbers on top of the boxes. There's 99 of them. We mentioned the mailboxes, the RAM. What we see over here are the individual RAM spaces, and then we can tell the computer exactly where to store the data we want. So let's just tell it to store it in, let's say, number 5. So let's make it store the data in 5. So STA05 to tell the computer that store the data that the user will input at box number H at box number 5. Okay. Now let's move on to the next one. So we said we want to make a program that will take data from the user and do additions on it, right? So now it takes input from the user, it stores it at number 5. So that will mean it will take the first number, store it at number 5. Let's write another. Since we are adding, let's add 2 numbers. We take the second input from the user. And after taking the second input, we are going to do addition, right? So then we take input from the user. We have stored it in number 5. Now we take input again from the user, and now we are going to add it. So now, what is the code that says add? What is the instruction that says add according to what we learned right now?
ADD.
ADD. So it's exactly as its name suggests. That was a dumb question. ADD. Yeah. So since we are adding, we need to add something to something. We took the first input, we stored it in 5. And then we take the second input. We are going to add the second input to the first input. So you say you add it to the data stored in number 5. Is that clear? So we take the first input, we store it in 5. Then we take the second input and we add it to the data stored in number 5. Now, after adding that, what we want to do is display what the results will be, right? So how do we display? What instruction is used to display the data?
Out.
Out. So OUT, out. That displays the data. And then after it displays it, we have to stop the program from running, else it will run indefinitely. So what instruction do we use to stop the program from running and from running again?
HLT.
HLT, excellent. Okay. That's nice. We are following. So then HLT to say false. So now this is the very program that we are going to use now. So this means we are going to give the computer an input. We store that input in RAM number 5. Then we give it another input, and then we add that input to the input stored in number 5. Then it displays the results. And after displaying the results, the program halts. Yes, appear somewhere. Someone
Okay, so
appear.
good evening.
Good
Yes,
evening,
yes, sorry,
boss.
good evening. I wanted to find out if it is necessary to give out a space when you are doing with your when you are giving the instruction for where you are supposed to be storing your data.
Oh, not necessarily. However, for
Yeah.
the beauty of the code and organization's sake, right? So it is
Yes.
not necessary. Yes, you won't run into a problem if you decide not to do that.
All right, all right, all right. Okay.
Yes.
Thank
So
you,
that,
sir.
yes, no problem. So now let's run the program. Remember what this program is supposed to do. So please, before we run the program, can you predict exactly how the computer is going to flow if we should run this? Who can do that? Can someone raise their hands and predict exactly what is going to happen if we run this? Okay, since no one is owning up, let's do the prediction ourselves. So the computer is going to use the INP, the program counter. Okay, the rewind, yes, the rewind.
So the little one computer will ask us to input a number.
Yes.
So after the input, it's going to store the number in the memory.
Excellent.
Right. It would then ask us, because since the first digit has been stored in the memory, it will ask us to store the second digits, because we have to input two numbers. Right.
Yes.
So after inputting the second number, it is going to add it to the first number,
Excellent.
then give us the result.
Simple. Cool.
Then after that, it will help. Yeah.
Excellent. Thank you, Mr. Boy. You have been really contributive to this class. And if I knew you, like, I'll give you 3 handshakes. All right. So each line of code here, remember, the program counter recognizes it with numbers. This is the first line of code, and it will be recognized at 00. So line number 1. Counter recognizes them as 0001, recognizes this one as 02. Oh. So it recognizes this one as 02. And then recognizes this one as 03, recognizes this one as 04, recognizes this one as 05. So do you notice something with the program counter? Currently, it is set to 00. This means immediately I run this program, it is going to input line. It is going to run line 0 first. And after running line 0, it will update to 01, meaning that, yes, why?
Please, I have a question.
Yes, go ahead.
So from the instruction we've given the computer now, I can
Yeah.
see the first line, the second, after inputting the number, it is going to
Yeah.
store it. But for the
Excellent.
third line, we inputted the number and we didn't ask it to store the number. Why? We just went straight for it to ask it to add it to the first number.
All right.
Why didn't we
Thank you.
store it before?
Okay, so now there are instructions that you can actually give it to store. But look at this. If we store the data in box 1 and we store another data in box 2, the addition now will cease to be just add stored. See over here, it says add the inputs in the second box. Sorry, it says add the second inputs to what is stored in the first box. It's a simple line that says add
Okay.
05. So currently, this is the limitation of the exact instructions I have shown you. But there are further instructions that will
Okay.
allow you to retrieve information from different storage areas and then use them simultaneously. Okay, so because of I'm
Okay.
showing you only a few. We are only using introductory instructions. This is a limitation that we will have to deal with. However, as the lessons progress
Okay.
further, we'll be looking at ways to retrieve information from different storage areas and combine them. Okay, so for now, we will only store the first value. We can also store the second value as well. Yes, we can also store the second value as well. Yes. All right. So then we input, we store, we input again, we add to the stored, and then we output and then we halt. So now, enough talking. Let's run the program and then see what it does. So let's all pay close attention. Let me reduce the clock speed a little so that at least our eyes can trace. So if I run the program, it says the input says what? User inputs. So I'm going to enter a number. Let's choose a simple number like 5. Then I hit OK. Then it has stored it, and now it's asking for the second user inputs. So I'm going to add a number like 9. So then what should our output be? I've inputted 5. You can see that 5 has now registered down here, right? So it's now an input. So if I do 5 plus 9, I should get 14. So if what we have done is right, let's see that. It gives an output of what? 14. So then look at what has happened here. It has given us an output of 14. The program counter has counted line 1, line 2, line 3, line 4, line 5, line 6, and it is now standing on a new line that has not yet been given, line 7, telling the computer that progress. Telling the computer to progress further. Okay. So what you see here currently is the program counter telling the computer to follow on to the next instruction, provided there is another. And then obviously the next line is an empty line. So it means the computer just halts. The computer just halts. And there are actually codes that you can write. There are instructions that you can use to get the computer to loop endlessly. Okay. So currently, we have told it to also stop here. And now you can see what happens here. It says that the current instruction is now 000. This means there is no current instruction. And it also says that the memory address register is 6. Do you remember where we stored our inputs? Number 5. If you come to number 5, you can find exactly what we stored over here. Okay, so exactly what we did, we find it's exactly over here. So where we store the data, it has gone there. Okay, all right. So this is basically what the little man computer is, and this is how it functions. Okay, so I'm going to give an opportunity for you to ask questions, and then we move on to a different example as well. Okay, okay, Derek Boyne, let me hear from you.
Please, can the instructions be written? Are they always supposed to be written in capitals, or it can be written in small letters?
Okay. So as I mentioned earlier, they must strictly be in capital letters.
Okay.
Please. All right. There was another hand up. Please go ahead and ask your question.
Sorry, sir. I follow the
Please,
same
can you do the
instructions.
addition again? I didn't see that part well.
Okay, no problem. So please, before this, the speaker right now, there was someone was saying something. You were saying you followed. Please continue.
I said I followed the instruction, but I had 9.
You followed
So,
the instructions.
I had 9 instead of the 14.
What did you combine? Did you do 5? Were your inputs 5 and 9?
My input, yes, please, 5 and 9.
Okay. Can you tell me exactly what your instructions say? The program instructions on this side. Can you tell me exactly what they say?
On which side, please?
On this side, you see where my cursor is right now? INPSTA, blah, blah. Can you read to me exactly what is written there?
Okay, let me see. I have to. I'm coming. I think I have to make it big. I'm telling you.
Come again.
The program encounter area, program counter area,
Yeah.
or which area?
No. This region. You see the white space on your computer. The white space where the programs are, the instructions, where under load programs.
Under load program, I have the IMP, I have the STA to be 05.
Good.
Then another IMP, then I have the ART to be 05, and then out, then HLT.
All right. And then please run your program. Hit run program again, and let me see something. So hit run program.
So they asked me I should put I should do the user input here.
So give it 5.
5, okay.
Press OK.
And the second one too.
Give it 9.
9.
Good. Press OK.
Yes, please. I still have the input should be 5 and 9, but the output is 9.
Your output is 9.
Yes, please.
Okay. So can you? I want to see exactly what your screen looks like. So I want you to. I won't say share, but can you take a picture of your screen, send it to our WhatsApp platform, and then
Sure.
I will. Yes. So send it to the L200 BSc WhatsApp platform, and then
L200. Okay.
I'm also facing the same issue.
You're also facing the very same issue.
Yes, that's correct.
Same here.
I'm also facing the same issue.
How many of you have successfully executed the program? If you have successfully executed the program, please let me know.
Yeah, hello, Mr. Prince. Please, do you know where the problem is? You see,
Please
at the
enlighten me.
far left. Please, can you hear me?
Please, I'm listening.
Yeah, at your far left end, right, where the input and the storage is. You see, I don't know what you did before you had the 0000102. So that place, you have to take that place again. Then I think that is where the problem is coming from.
Okay, but Vida, were you able to do that? Were you able to? Was your program able to successfully run?
It didn't run.
So did you hit run program and then that's what happened?
Yes, please, I did.
Okay. All right. So every single one of you is facing the same thing, right?
That's what I'm saying. The
No.
problem is coming from the load program in RAM, no? At
Yeah.
that place.
Yes.
There's a problem. Yeah.
Okay. Yes. Yes.
You see,
Thank you.
at the central processing unit, the program counter, I'm having 6,
Good.
and the I'm having 5.
Good.
But the
So your
MDR
memory.
is 0, 0, 0.
Good. So it
And
means
then,
there is
mhm,
Mr. Joshua, there is a line missing from your code. If you said your program counter is having 6,
yeah.
there is something your program counter is not reading. Because if it is having 6, then it means it has overlooked 1. If you have a halt there, the program counter is going to go from 0 to 1. So that's going to be 1, 2, 3, 4, 5. And this will be the set one. But after the set one, it skips to a 7th line that is not existent. So if you are on 6, then it means your computer is running only 5 lines when it's supposed to be running 6. Because currently, the numbers you see here, they don't mean anything, okay? I put them there to tell you the exact positioning of the, what do we call it? How the program counter reads the lines. So let me just clear them from there, and then we do it again. And if you are facing that, I'm going to have you do something right now, and then we see if it sorts out your problem. Mr. Joshua, please, have you taken the shots and then sent it? Can any of you take a shot of your
Yes, please.
screen?
I've done it.
Is it on the L200 BSCIT platform?
Sorry, I put it on the coordinators platform. A minute, please.
Okay. Don't worry, I was.
So I've done the right thing.
Let me check it. All right. So you have inputs store at 5, and you have inputs again, and we have add 5, and then you have outputs, and then you have halts. Yes, Mr. Kwame Moses, do you want?
Please, I think what Vida is saying is right. Initially, I I ran the program without the adding the lines. That is 0010, and then I was getting the same value. He had 9, but later I changed and then I numbered the lines, and then I had 14.
Okay, so this is how, wait, are your programs against the wall, or is there a space between your wall and this? Like, are they space like this?
Yeah,
Or they are?
initially it was against the wall, but now if you also indent it, then it will run normal. It will give you the 14.
Yes, so that's where the problem stems from. So I'm saying that the numbers don't really matter, okay? But the problem was with the fact that your programs were against the wall. But the numbers, they don't really matter though. The numbers, I was just using them to show you how the program counter reads. Is that right? So, okay. So, Mr. Joshua, has your problem been solved?
Oh, so I should.
No,
Okay,
it's still
let
like
me
that. 9.
let me try it and see.
Yes, try it again. Okay. So, Mr. Joshua, add the numbers to it now. Your 0, 0. Then this means that you are
Please, you
explicitly
would have to
telling.
add the numbers.
So add the number. This means you're explicitly telling your
Yes.
computer to, your program counter to read these lines in this order exactly. Okay.
Okay, 000102.
0,
Okay.
yes. So then it means you're telling your program counter to explicitly follow this exact order.
Okay.
Yes, please. Okay. All right. So now run the simulator again and see what happens. So please, have you all corrected that? If when you did that, has it successfully shown the expected result?
Yes, it's working if you add the numbers.
All right. Okay, that's very powerful. So I like that we are seeing problems of it. Okay, Mr. Abwaje Prince, let me hear from you.
Yes, please, I am not getting an output at all.
I'm not getting an output at all. Do you have the line that says OUT?
Yes.
All right. Please take a shot of your what do we call it, and then send it to the platform, and let's address it the way we did.
Okay. Sorry, I see.
All right.
I think
You've noticed
yes,
the problem.
I
Right?
made it
All right.
0 UT, I think.
All right.
So I'm running it again to see if I'll get to the right.
All right.
It's working. Thank you.
That's okay. That's powerful. Okay. So now, here's what I want everyone to do. Okay. I want you to take this very program that we have written. Now, add a line that is going to subtract. Okay. So instead of doing addition, I want you to give it an input and add a line that is going to subtract those two inputs. Okay. So instead of adding, let it rather do a subtraction. And then take a picture of it and put it in our chat right here. I believe our chat is active, right? So you can just take a shot of it and put it in our chat and let's review it. Mr. Moses Kwame Jiwonu. Someone is asking for the setup of Little Man computer. Please go to the level 200 platform, the IT one. I've put a link there. So just go there. You can access it. You can access the web version. Mr. Moses Kwame Jiwonu, your hand is up. Please, you may speak.
Hello, sir.
Yes, boss. You're audible.
The accumulator displays 14, but the output is not displaying.
The accumulator displays 14, but the output isn't.
The output is empty.
Wow. Okay. So I'm coming. You are sure? Do you have output there? Did you code the line that says output into the what do we call it? Into your program?
Yes, please.
OUT.
Yes, please. OUT. That is 05. You know, I have 0002, 03, 04, 05, and 06.
Okay. All right. So
now everything is correct,
Yeah.
but the output is what is not showing.
Mr. Evans, yeah, please, welcome. Mr. Evans has joined us, so I think he wants to address some of these things. So please, let's listen to him briefly, and then we proceed. Okay, Mr. Evans, please, you can come in. All right, Mr. Evans.
Yes, sir. Am I loud and clear here?
Yes, boss.
Good evening, everyone. How are we all doing? I hope we are enjoying the session. Hope we are all enjoying it. I just want us to note that a lot of these sessions will be happening. And we will all be benefiting from it. Anytime the announcements go out, try and do well to be part of it. This would help you in your exams. There will be item testing for exams as well. But we will not come and be telling you that this is it, this is that. You get me? So it will be part of the lessons. And then after these lessons are over, this semester, we are beginning it um, very early because we want to be able to be ahead of the class each time, so that before a lecturer would have a session, we had already gone ahead. And so you will be able to understand everything the lecturer is saying, and then also get a lot of additional info from the lecturer. You get it? One of the things we will also be doing is intermittent assignment here. So you will see sometimes maybe in the form of objectives. After, that's why we are beginning very early. We'll be having, so you will mark, you do it, and then it will mark by itself. And then by the time you are done, you will see your scores automatically. You get it displaying over there. So all these things for all the courses we are doing this semester. So imagine 6 courses, right? But you see, we have our people who are also doing it, right? And we have tutors coming over to come and teach us. You see, some of them are our colleagues in the industry for so many years. You can see from today's session, right? And we are going to have for the other courses too as well. So all the 6 courses for a token of 270 cedis. Isn't it amazing? 6 courses. So even if you have to pay 100 cedi for each course, you get me? How much is it going to be? You see, so all the 6 courses for 270 cedis. It's going to do a lot to help. And so you can reach out to the team. Mr. Anan Joshua is here. You can raise your hand so that they'll see you, okay? Other than that, the team on the WhatsApp would direct you if you are interested. When you reach out, the number will be given to you, to any of the admins on the WhatsApp platform. So please, if you are not on the WhatsApp platform, wherever you got the link, try and ask the administrator there or the admin on the platform or whoever posted the link, follow up with the person, and the person will lead you to do your payment, and then you will be translated to a page where you see, as this lesson is going on, it's being recorded. So even what I'm saying here is being recorded. Okay, so it will be available to those who would go to that extent, those who will be doing the payments. Okay, they will have access to all this. So imagine you are in this class, you've been able to ask questions, and then you finish too, you have videos in addition. Isn't it awesome? So let's do that, and then it will encourage our tutors to continue to help. And then if there's any exam help too, we will also get hold of it. You get it? We will also get hold of it, and then we aid in our preparation towards acing our papers. You get it? So let's take note of these things. So today's session, you realize that it's free, but another session is probably not going to be free. You get it? So also, if you are here and you are not on the level 200 BSc IT page, you can reach out to the person who shared the link with you, so that they will let you reach out. Mr. Ajekum and Mr. Abuaji, I see your hands up. You can ask a question after the information, okay? All right. So this information is very, very important to the next session that we will have. So if you are having financial challenges and you were part of the last semester, those people who paid, there will be a discount or a payment plan for you, because you have exercised a certain level of maturity last semester. You will be given more opportunity, right, coming this semester. And so if you want to have more opportunities come next semester, you can be faithful in this semester's own, and you'll be granted more opportunities, just like those who were faithful last semester, right? So if you were not able to pay in last semester, but you were able to have access, don't worry, don't let it stop you from joining. Okay, you are still a member of the family. Okay, we understand the starting of everything is difficult sometimes, and we understand the challenges that people also face financially. But we can allow certain people, but not to a certain extent, right? Other than that, we should also try and do things for everyone. You see, at a point, it will not become fair. So we'll do very well to consider people with financial difficulties, right? So these people, because we need a lot of hands actually. If you want to help with a team, can join, but we would need a lot of hands. So you can't come and say, oh, I need help to join the class for free, but I can't do anything to help. You see, it means that genuinely you done your mind that, oh, at the end, you know what to. So if your rep team has come together to do this very powerful session like this for you to be able to pass your exams well, you should also communicate in all good things, right? It's very, very important. So as I'm speaking, you can DM any of the administrators on the page, right? Especially those who are here. Okay. This is why I entreat most of the admins to have the names on their WhatsApp so that people can locate them easily on the platform. Okay, so but Mr. Annan will raise his hand again so that you see him, so that you can reach out to him. I think he and Mr. Kwenu shared a lot of the links on the page. They are part of the publicity team, so they are helping. You can reach out to them, DM them. I see his hand raised again. Okay, he would, or they would guide you into joining the session. You might not see any free session until maybe another time, somewhere. Do you see? So try to reach out to express your interest, and we'll take it up from there. Okay. We have payment options for those who took part last semester. Payment options. We might have payment options for certain people, but if you've not done, if you've not joined us last semester, okay, try to pay upfront, or you can do 70%, then do the rest later. Do you get it? Anyhow you do it, okay, because this is very, very important. And you know, with the 270 CDs is like it's come on for 6 courses. You get me? It's not much, because if you have to pay even 100 for a course, look at it. So we are doing it so that many of our people can join and then be able to partake and not get lost in class. Because trust you me, a lot of our predecessors, right, have resit for DCIT 207. You see, most of the courses this semester, a lot of our predecessors, they have resit. So it's very, very important because they got lost. I'm trying to do my best so that no one would get even a D in this course. You see, so that we all can do well, at least a C for everyone, if we will be serious. Okay. So if you don't have a laptop, try and get a laptop so that if you don't have a laptop too, you can reach out. Those who don't have laptop, you can reach out. Arrangements could be made for you. You may never know. Okay, but try and pay for the classes first. Then we'll look at also payment plan for laptops and all those things, right? I understand that some of our people are into some businesses that can also help. So this is where your business come at play. But I'm not saying go and do adverts on the page. Those who have been doing adverts on the page, please, if you see someone there, delete it, or let them draw their attention to it. Because if we all are to do our business advert on the page, nobody will have their peace of mind. Okay, so those who have been putting our TikTok on the page and all that, you see. So let's take notice of these things. Very, very important. Okay, I think the team will be reiterating some of these things so that we get them. Okay, I have 3 minutes more. Those whose hands were raised, I hope I've answered some of your questions or your doubts, right? Okay, Mr. Abuaji, yes, sir.
Yes, so thank you. I was going to ask about we that we are coming from other schools, diploma to degree. Is there any special plan for us also? Because we probably, we're not here last semester to join the classes and other. And also, we are doing more than 6 courses. So if maybe you have this same plan for other people that we can join somewhere else, I don't know. We are doing more than 6 courses. We are doing some courses with the level 100s also. So that was my question. Thank you.
Okay, so if I understand what you are saying, Mr. Abuaji, you are a diploma to degree course student. What I know is that the diploma to degree students are supposed to do 7 courses, okay? 7 courses. And the one that makes it 7 is critical thinking. Okay. So apart from the 7, we are doing all the 6 on our page. I would later have another platform separately, right? For those of you who are doing critical thinking, because we'll be having study classes too there, studies just like these ones for critical thinking, okay? And they will be preparing you for the exam. So you will see me teach there. One of the advantages is that we have a little experience in that, and we have some even questions. We have a lot of questions. So the session for session 1 of critical thinking, we have about 50 questions set already. Session 2, we have about 40 questions. Session 3 and 4, we have combined. We have about another 50 set of questions. So each session has a series of questions. You get it? So by the end of the critical thinking sessions, you would see that you have been well equipped and ready for the exam, right? And so don't worry at all. I'm working on getting the level 100 link for all those people, your colleagues. So I'm taking note of all your colleagues, okay? And try and join let me know if you are on the level 200 platform for BSc IT students, okay? If you are not, you will be added. Ask the person who shared the link with you so that you'll be added, okay? It's the same to everyone who is not on the platform, especially the diploma to degree colleagues, okay? I think I've answered you, right?
Yes, please. That answers my question. But then also, it's not 7, it's 8 courses. We're doing academic writing 1 also. So you should take note of that one.
You are doing academic writing 1 too?
Yes, please. Academic.
Wow, because I'm aware of only 7 courses. So
Well, I'm doing 8. I don't know for others, but then I was asked to register academic writing 1. So
wow. Okay, don't worry. I'll reach out to you and we'll rectify that, okay? If you have my number too, you can reach out directly. Other than that, try and get through to the person who shared the link, and then I'll direct you, because most of your people have 7 courses, okay? All right, so that you'll be guided, okay? Is that all right?
Thank you. Yes, please. Thank you.
Awesome. I think, yes, sir.
Yes. Your number. How can I get your number?
Yes, someone will post my number on the page right now, okay? Mr. Jekum, your hand is up.
Yeah, Evans, good evening.
Evening, sir.
Please, it's about the classes. So if I want to make the payment, whom should I make the payment to? And then if there is any link,
Yes.
right? Because I wanted to join the class. That's all. So if I
Yeah.
want to
So,
make,
WhatsApp. Okay. So, anybody who wants to make the payment, you reach out to the person where you got the link, the person who posted the link on the platform. You reach out to the person, you'll be directed, right? But you have to check whether the person is an admin on the platform. Okay, you realize that the person is an admin on the
so
platform. Then,
Ivan, so why
yes,
why
sir.
don't you post the link on the platform so that everybody will know that like Evans, because some of them we don't know that maybe someone can also just post any link, then we follow, then you do the wrong payment. Do you get me?
That's
So if
awesome.
you do
Awesome.
it,
So,
then everybody may know that you are the one doing it, so we can follow.
okay, good idea, sir. Okay. Actually, there have been series of meetings that have gone behind this thing. So, what will happen is that the team would post the mobile money link number on the page. So when you send, you send your proof of payment, right? And then like including the name, then you'll be added to a platform, okay? On the WhatsApp platform where the tutors, every one of the tutor is on, and any question is answered. So when a practical question is given, you can follow up back on the page and then ask questions, further questions on the page for you to get clear understanding. Okay. So the number will be posted, the WhatsApp number will be posted with the details. So that number would also be on WhatsApp. So when you send, then you message with your proof of payment, and then you'll be added on the WhatsApp platform, and then everything will be taken up from there. I don't want to be the one handling the money. If you guys think I'll not handle the money, because this semester I have a lot. We are going to have these same classes in another uh, place. Okay, we will have more. We will have more class. Please, I'll not handle the money. I beg you, please. The number they will put, I'll let them post on the page. Okay, so you'll see me like it. You'll see me reply that message with a thumbs up. You get me? And it will be posted on the announcements section too. They are all here. The coordinators are here, so they are listening. They are preparing the message as I speak. Okay. Mr. Jekum, your hand is still up.
No, I'm okay. My question has been answered.
Okay. So because there are lots that will be, you see, some of us will be teaching like 4 to 6 courses. Maybe only one of mine will be IT related. The rest will be commercial law and all those things, which most of you here are not doing. All of us here are not doing. Do you get it? I understand that some people join from Bachelor of Arts and are listening to this thing because they are also waiting for their side. Do you get it? So please, I'll be too hot. Okay, so there's a whole team in charge of everything. Mr. Darkon, who is the coordinator here tonight, is one of them. And you see the organizers at the top. Okay, they are all tutors as well. Okay, and so watch out for them as well. Okay, so let me end it here so that session continues, sir. Any other question and before the tutor continues? Is someone having a question? Okay, all right. So actually, anybody who is also able to bring someone, maybe your money, you will get a discount. Okay, so if you're able to pull, let's say 2 people, there's a level of discount the team will grant you. Okay, so they will be working on that too as well for everyone. I think it will make it interesting and it will get everybody involved, right? And the idea is to help, but at the same time, we must help those who are helping us. You see, it's an ecosystem. So we have to maintain it, okay? And all of us will be blessed. You see, the one who is giving must also receive. Otherwise, it's not complete. Because if you give to the ground a seed, the ground must give you a tree. You get it? It's a spiritual principle, it's a natural principle as well. Okay, so let's all be blessed and enjoy the rest of the session. Mr. Dako, over to you, sir.
All right, thank you very much, Mr. Evans. Okay, so everyone, back to the lesson. I think I was saying that we should create a same program, but this time for subtraction. Our time is almost up, so let's view what we have done. So I see Mr. Richard Rue, you have put a program here, and then it's perfectly correct. So if you follow what Mr. Rue has, his program says, yeah, all right. So it says you input, you store at 5, you input again, you subtract 5, and then you bring the output and you halt. So then look at what he has. He inputted the value 10. It is stored at 5. Then later, he inputted the value 8. You see that? So then that's the second input. And now he says subtract 5. It means take the 8 and do it minus what is stored at 5. So 8 minus what is stored at 5. That's 8 minus the 10 he inputted. That gives you minus 2. All right. Okay, so now on the platform, let me see. I can see some interesting ones there too. Basically, they are the same thing. Here we are. Right. So, Mr. Joshua, I'll address your problem after I review these ones. Okay, I think I see what is happening. Okay, so here's Vides program. If you can see it clearly, I believe you can all see it clearly, right? So she has the input and then a storage and then input and all the way to the subtract 5. So her initial input is 7, and then she says subtract. So now she enters 3 and says subtract 3, 7 from 3. That's going to be 3 minus 7. That gives you negative 4. All right. And then there is also another. This is from Joel Akota. And then his inputs, this time his inputs initially was 5. Now he says subtract 5. So subtract the thing stored inside 5. He stored 5 inside memory space 5. So he subtracted the value stored in 5, and then it gave him the answer 4. So it's going to be 9 minus 5. That gives him 4. Is there more? And here's another from Carl. Carl also does same, and his initial input was 5. So 5 minus 8, and then he got 3. And then here's another from Prince. His initial input was 11, and then he did 28 minus 11. He has 17. So I can see that the objective for this lesson, despite the fact that the lesson has not yet ended, has been met. And then I am very proud of everybody here in our effort. Now, Mr. Joshua, let's see what happens here. Mr. Joshua says he runs his program. However, when he does, he finally runs the program with this very same setup here. The program is displaying, Mr. Joshua, what did you say the problem was, please? Please speak up. What did you say the problem was?
After the numbering, I had the correct answer in the accumulator, but it's not displaying in the output.
All right, thank you. So let's see what is happening here. So everybody, trace your eyes with me all the way to this side, okay? You see the memory addresses here. There is 00, there is 01, there is 02, there is 03, there is 04, and then there is 05. What we do not see happening here is that apart from the fact that we are also giving the computer places to store our data, this 05 here, the machine automatically also stores all the data that we input inside its memory. Because if it doesn't store them, it will not be able to reference them and use them for instruction. So it has actually stored all these values you are seeing here. It has stored your inputs. It starts all the way from the top and stores them exactly as follows. So it stores inputs in the first one, stores this in the second, stores this in the third, stores this in the fourth. It keeps following all the way. So it's stores. And then you see there is a problem here. By the time we would have gotten to address number 5, what is it storing there? It is already storing the halt program. So it's storing the halt code on this side. And that is where your program is running into a trouble. Now, the rest of you whose programs are successfully running, what this tells me is that the computer has been smart. So the memory state right now, the memory state really matters when it comes to the computer. Currently, what the machine is doing, we are doing shared memory. It is automatically rerouting halts, giving halts a new destination. For those who have stored the value inside the halt location, that's number 5, it is automatically giving halt a new location, and that's why the program is not getting the error that Mr. Joshua is having. But then, Mr. Joshua, your program is the one that I'll say is running kind of very normal tonight, because it has acknowledged the fact that you have stored 5 at where the program is supposed to halt. Because as you can see, is the fit instruction. And then the fit, as I said, every instruction is stored in one memory space. So currently, halt is already stored at 5. And then it is not allowing your program to overwrite your value. Now, there are ways you can go about this. One of the ways is to change Mr. Joshua. So since yours is not permitting your the use of the same place that is storing that, I'll tell you to change this. One of the ways is to just change this memory location, change it to something that is higher up the chain, like 10. So for 10,
okay.
so there for 10, we are not using it. So change it to 10 and hit run
Okay.
program again. Run program and then do that. Let's see that.
So I'll enter 5 and then 9 again.
Yes, try that.
And then I'll enter 9. Hey, I'm getting a huge figure.
Hey, wait, you did your
I'm
Mr.
getting a
Joshua,
very huge figure.
your machine is
Hello, Mr. Prince.
yes, Vida. So wait, please, Vida, I'm coming, okay? Mr. Joshua, there is another way you can do it, and that is by specifically telling your computer which of the storage areas are being used for instructions and which of the storage areas are being used for data. So, for example, for this data line we've written here 10. So we are going to go back to the code that one person, and Mr. Freeman mentioned that there is another one called Dcit. That one is used to tell the computer that this particular location is holding data, so don't touch it when you are running your sequences. However, I won't advise you to use that right now because it might interfere with your program, but you can tell the computer that memory location 10 is holding data, DHC. So then, if you write it as data 10, data 0 like this, you are basically telling it that this guy here is holding data. So no matter how far you go, no matter which storage you use, make sure you do not touch 10. And then that will only work. But then in your case, as you're saying, it is displaying a
Now,
huge
wait,
value.
I think I have identified some
Your
issue.
problem.
I think my numbering was wrong. That's why sharing screen is important.
Hi, Mr. Joshua.
Yeah.
All right.
So
you're right. So that's why
I'm correcting it to see if
all right,
if
try
it
that. So
will
Auntie,
work.
Madam Vida, as he does that, please come in here. So please come in. I think Vida has been very contributive, and I think she has given us some good pointers here. That's
Yeah,
very
please.
good.
So that was what I was about to say. And like I was thinking of maybe he should write something like loop so that the how do I even say it? So that the program will loop and it will overlook that numbering so that it will display the outcome, the output.
Okay. So he should rather loop the program so that it goes all the way to the start and then runs through that very same site.
Yes, that was
All right.
my suggestion.
That's always a good idea. And then a loop, as she has said,
so it's true
a
now.
loop is true. Okay.
Yeah.
So then it was your numbering that was off.
Yeah. I think I jumped from 01 to 04. So I was having 06. I checked yours was 05, so I have to do the correction. And it's true now. Sure.
Right. So please let's remember that when we are right. So thank you, Madam Vida, and thank you, Mr. Joshua, for bringing those mistakes to light so that we can avoid them next time. Let's remember that when we are writing our codes, they are very case sensitive, storage sensitive. They matter which storage you are choosing. Okay. And then the numbering, when you show the numbering here, you are telling the code the exact order it should follow. Now, this numbering is not always needed, especially in some other LMC simulators, they overlook the numbering problems. However, the only challenge you'll be facing is For example, in what we were doing. So you see, Mr. Joshua, you mentioned earlier that after you were running it at first, all the program was displaying was 9. If your machine is in a strict memory state, because what yours has displayed that, it is going to try using random memory locations to display values. So this means it will be storing its halts somewhere, probably storing its halts after your first input. So it could be storing halts after your first input. And this means after your first or second input is given, there will be no addition whatsoever. And then it will just display a random number that you entered. So it's important that you know. So the numbering that we did here added later was to tell the computer that this is our first line. So program counter, take this guy first. This is our second line, program counter, take him next. This is our third line, program counter, take him next, all the way to the end. So then we have told it explicitly which exact order it must follow. So sometimes just listing them might not be enough. If your machine's memory state is not favorable, or if your LMC is very strict. This one, it is quite strict, but then I can see, despite our small problems, it is allowing some of us to do some things. It will be giving you these constant errors, and then you will have to check them. Okay. So everyone, there are other ones. There are branch codes. There are branch codes as well, but we are not going to look at them today. But then here are some of them. BRA. This one is a branch always. And then this can be used to generate loops, even without using a loop. We'll look at that maybe if we are all here and we meet the next time. And then there is also a branch if 0. And then there is also a branch if the value is positive. All these ones can be used to write codes to select particular factors. So these are like if commands. So they are conditional commands that tell the computer a decision to make. We'll be looking at all these ones later. We also mentioned that tells the computer that this place holds data explicitly, and etc. etc. But in further lessons today, I don't want to bombard you with too much because I think the introductory lesson in itself has even met more than what the lecturer took us through in our first lesson. I believe this lesson has been helpful. If you have any good questions or any suggestions you want us to hear, you are allowed to speak. Just raise your hand and then go ahead and share it. We have exactly 11 minutes to stop the lesson. Yes, Mr. Ajefum Frank. Mr. Frank Ajefum, you may speak.
Yeah, hello.
Yes, sir.
Yes, friend. Please. Yes, can you hear me? Can you hear me?
Yeah, I can hear you. No, Mr. Frank, I can hear you.
Hi, please. Some of us we are not with our devices. So
All right.
after this session, can you please send the recording to the platform so that when you get home, then you can able to get access to it.
Okay, so all right, so we are going to have to upload the programs on YouTube, right? And the videos. However, you can access them in the chats. So we are going to also see if we can make them available in the chat. But mostly we get problems from people saying that since they are not using their school emails, they're not able to access those ones directly. So we are going to upload it on YouTube. It will take us a few hours to do that. And once it is up on YouTube, we'll share the links and then you'll be able to visit the site, the YouTube platform, and then follow through. Is that okay? Mr. Frank, is that okay?
No. Okay, it's okay. So please one more question. So if I'm doing it, then maybe I'm not able to get the destination. So can I contact you? So am I going to get a response from your side?
Okay. Hopefully you will. Hopefully. Okay. If you contact me, hopefully you'll get a response. If and also if you DM me and then maybe I'm not able to respond to it because I might be attending to something else, you can just go ahead and put it on the platform. You've seen that we have some very powerful colleagues on our team. There is Vida here, and you have seen what she is displaying right now. And there's also Mr. Boahin, and he's also showing some very powerful contribution. There's also Joshua. If you put it on the platform, every single one of them will be very eager to help you in any way they can. And then if you put it on my side and I happen to see it too, why not? If I have time and I see it, I'll totally be willing to help.
Okay. Thank you very much.
No worries, brother. No worries. I saw there was another hand up. Please, you may speak. Okay, so if you have something to say, speak now or hold your silence forever. Okay, so we are done with today's session. I hope the session was helpful to you. I hope your confusion from the first lesson have been cleared, and I hope you are ready for the next one that will come. Remember what Mr. Ivan said, that if you do not reach out to us concerning your interest about it, we are going to make our links available. However, the joining will not be possible because Mr. Joe, I've seen your number. Please, I'm coming. Okay. So the joining will not be possible unless you have been added remotely as a participant. So you should make sure that you have reached out to the sharers of the link. We are going to provide particular names on the platform. You will see my account is saved. So if you see my account saved with an emoji, that is my account. I personally am going to post particular names with communiques, and then you are going to see them on the platforms as well. I'll point you out to them so that you won't end up falling a scam to someone's, or you not end up falling to someone's scam. Mr. Joel, please, you may speak.
Please, the first example you did, the storage was 0.5 and the SAP was also 0.5.
Yeah.
But I tried to change it to maybe 0.4, then the SAP also 0.4, but I didn't get the expected output.
Yes, so Mr. Joel, I just explained concerning that, right? Thank you. I was saying that the instructions that you see written on this side of the screen, right? The computer also stores them. So the program also stores those instructions. So if you check here, look at this carefully, you see 00. Even though I have not stored any information there, 00 has something recorded in it. 01 also has something recorded in it, even though I've not explicitly stored information there. So does 02, so does 03, so does 04, and then 05 is the only one empty. So what this means is if I decided to change my memory address right now to 04 is holding one of the instructions currently. For example, it is holding outputs. So I am trying to store data somewhere that is already full. And then the computer is going to start overlooking my instructions because the memory address that I am referencing has already been occupied. So to keep yourself safe, try to use something that the computer will not use. Currently, I have 5 lines. That makes 6. You can store in an address like 10. And then the computer's codes will not interfere with your storage area. Okay? Or you may do what I said. You can tell the computer explicitly that I am storing something in 04. So don't use 04. And then if the memory state is permissible, it will allow it for it to work. Okay. So Mr. Joe will change your storage area from 10, from 4 to something higher like 10 because 4 is being used by the computer. And run the program again and see if you run into the same problem.
Okay. Okay, it works.
All right. So thank you, bro. Thank you. So please, is there another question? All right, there are no other questions, right? So then we can bring the curtain down on today's meeting. It has been a great time with you all tonight. I hope you have a great sleep. Your evening go well as well. See you next time. Goodbye. Good night.
Thank you so much. God bless you.
Thank you. You're
Bye-bye.
welcome. You're welcome. Goodbye. Who is that?
Right, welcome
Late.
back.